Hey there, going to quickly try to explain seasons and the amount of solar radiation that the Earth receives on the different seasonal dates. So in your notes, you've got the autumn equinox, followed by the winter solstice, followed by the spring equinox, followed by the summer solstice. On each of those dates, the Earth receives different amounts of sunlight on different portions of its surface. So I've got my globe here, I've got a flashlight. We'll see if we can simulate the sun. So first off, on the equinoxes, the subsolar point is at 0 degrees at the equator, meaning that the Earth receives equal amounts of solar radiation. So half of the Earth is illuminated, half of the Earth is in darkness, so equal day, equal night, equinox. That equinox is kind of sounds like equal, because it means equal day, equal night. After the fall equinox, Earth moves around the sun. So when I've got a flashlight next to the camera here, here's the Earth and the sun. Notice you can see this line is kind of the separating line. You can see the North Pole, you can see the South Pole. As the Earth rotates, it gets equal amount of daylight, equal amount of nighttime, so equinox. Keeps moving around the sun. Now, because of axial parallelism, this North Pole, as we move around the sun, is always going to be pointed to the north, point in the same direction, so that when we get around the sun to a certain point, this axis is going to be pointed more towards the sun as we orbit around it. That means, actually it's the other way right now, that means that when this axis is pointed after the autumn equinox, when this axis is pointed away from the sun, it's winter for anyone in the northern hemisphere, it's summer for anyone in the southern hemisphere. And that's because of, again, axial parallelism makes so this axis changes the Earth's position to the sun, so that on the winter solstice, this axis is pointing away, southern axis is pointing more towards the sun. So as you can see, hopefully from here, the southern hemisphere gets more direct solar radiation. On the winter solstice, December 22nd, the Tropic of Capricorn, way down here, gets a direct angle of solar radiation at 23.5 degrees south. It's direct radiation. So that's the middle of summer. That's dead summer for them. That's when they're getting the most direct angle of radiation for anyone in the southern hemisphere. Notice that as the Earth rotates, you can see all of the Arctic Circle down here. Anything south of 66.5 degrees south, you can see it. Sorry about the squealing. So that in the southern hemisphere within the Antarctic Circle, they actually have 24 hours of daylight for almost a 4-month period. It's really just about like 2 months on either side of the our winter solstice. It's summer for them in December. And then notice also as the Earth rotates, you can't see any of the Arctic Circle. So in the Arctic Circle in December, they have 24 hours of darkness for almost a 2-month period on either side of that December date. So winter solstice is a big deal. December solstice is a big deal for people in the northern hemisphere because there's more people living there. In the southern hemisphere, there's not that many people, and the only people in Antarctica are going to be scientists and like support teams for them. A little bit of New Zealand is affected, not really, like they're not in complete darkness. They're still 10 degrees of latitude away from Antarctica, from the Arctic Circle. But in the northern hemisphere, you have a lot of people that are potentially in complete darkness. So within the Arctic Circle, during wintertime, a lot of people go on antidepressants because not seeing the sun, it turns out, has a big negative effect on you. It's cold for a long period of time because for 4 months you don't get really any sunlight. Sunlight is what heats up the Earth, so it's very cold during that time, during the winter, December. The joke in Iceland is kind of right on the edge of the Arctic Circle, and there's a pretty good population in the capital. The joke is that they put antidepressants in the tap water, kind of how we put fluoride in the tap water here. They don't actually put antidepressants in them, but enough people take antidepressants that during the winter, that's what they say. And then in California, during the wintertime, that's when we get our least direct angle of solar radiation is during that December solstice. Okay, so we keep moving around the sun. We go to spring equinox. On the spring equinox, the Earth looks, compared to the sun, just like it did in the autumn. It's just on the other side of the sun. But again, you have equal length day, equal length night. Half the Earth is exposed to solar radiation. The other half is covered from solar radiation. So spring equinox occurs in March, on March 22nd. And it's the springtime. It's that halfway point between summer and winter. Now, continuing around, get to the summer solstice in June, the June solstice. It's summer for us, it's winter for the southern hemisphere. So on the summer solstice, the subsolar point is 23.5 degrees north. It's way up here. So everywhere around the world at 23.5 degrees north gets a direct angle of solar radiation right at this point. And then anybody who's near that 23.5 degree north line of latitude, we're in California, we're located at 33 degrees north, or 34, depending on where in LA you are. So we're 10 degrees of latitude away from that Tropic of Cancer. So pretty close, but again, you could be right on the Tropic of Cancer. So we will never get a direct angle of solar radiation in California. If we do, something very bad is happening. Then who cares about the seasons? But we'll never get a direct angle of radiation. But we'll get an almost direct angle. It's not 90, but it ends up being like maybe 80 degrees. I don't know. Look it up. Do math. But in the northern hemisphere, in the Arctic Circle, as the Earth rotates, notice you can see the entire Arctic Circle. So in the summer in the Arctic, they have 24 hours of daylight, of sunshine. The sun, is relatively low on the horizon. It doesn't get super hot because it's a low angle of radiation, so the sun kind of bounces off at that angle. That's not direct, but it is constant throughout the summer months for us. So that might be fun for a while, maybe for a year if you live there, where you're visiting. You wake up, it's light out. You go to work or school, it's light out. You come home from work or school, it's still light out. It's 10 p.m., still light out. It's midnight, still light out. So people actually put up blackout curtains. You can, cheap way to do that is just buy aluminum foil and hang it up on your windows, and a lot of people do that. Or you get the heavy blankets that you use during the winter to keep warm and just hang those up on your windows to keep the sun out. So you have an abundance of sunlight in the summertime in the Arctic. Just like it was in the Arctic in the winter, in Antarctica during the June solstice, they have 24 hours of darkness. It affects the people, yeah, but they're scientists and they signed up for it. They're getting paid to live there, so who cares? But yeah, there's a lower population in Antarctica than there is in the Arctic. And then we come around and do the whole thing again. So that is the seasonal start dates. And hopefully this flashlight here helped demonstrate the sun radiation on the Earth at those different dates. We go from the fall equinox, to the winter solstice, to the spring equinox, to the summer solstice. And at each one of those, because the Earth is moving around the sun, and axial parallelism, the part of the Earth that's getting a direct angle of radiation changes. Now, the Earth overall is getting the same amount of radiation, but it's how it affects the people on it. Now, if we didn't have a tilted axis, if Earth was just moving around the sun at a straight 90-degree angle, would we still have seasons? No, because one part of the Earth, the equator, would get the same amount of radiation all year long, so there wouldn't be any change. Now, would that be easier? Maybe. Now, things are cyclical, and air and water processes are cyclical, and maybe some cycles would develop in wind and water, but probably not. No, we wouldn't have seasons. Now, what if we were at a more extreme angle? Instead of 23.5 degrees, what if we were at 30 degrees or something? Yes, we would have seasons, and they'd be more extreme. So during the Pleistocene epoch, 15,000 years ago, and for the last really 2 million years about, Earth was tilted not at 30 degrees, but really just at 24. So that's imperceptible from this 23.5. And when we were at 24 degrees, that was enough to cause longer winters in the northern hemisphere and cause the growth of glaciers in the northern hemisphere, so that the ice ages, like you were hearing about ice ages, those were the Pleistocene ice ages or glacial eras. Those were caused by the Earth being tilted at a slightly increased angle compared to what we are at now. And when the Earth shifted from 24.5 back to 23.5 degrees, those ice ages ended because our winter becomes shorter. So it allows the ice to melt in the summertime more, so that ice ages or glacial eras end sooner. Great. Okay, that's seasons. Now, why do you need to know about this? These days, seasons don't affect many people, especially in Southern California. They like, people make fun of us because we don't really have seasons. It used to be that every person alive's life depended on the seasons. Seasons told animals when to migrate when it gets cold, so the animals would migrate to the south where it's warmer. When it heated up, animals would migrate further north where there's more water available. People would follow those animals and then eat them. Seasons told people when to plant crops, when to harvest crops, when to save crops, so that you'd have food. Seasons control the flow of water, where rains occur at certain times of the year, and that's different all around the world when rain actually occurs. Sometimes it occurs in the winter, sometimes it occurs in the summer, depending on where you are on Earth. We'll talk about that in a different chapter. But really, all aspects of human life that we rely on to survive are affected in some way by the seasons. So if you kept track of the seasons, you have a better chance of surviving. If you don't know what the seasons are, you or your people are probably going to die. And all around the world, you can find monuments that are sort of calendars that help track the seasons. Stonehenge is one of the things that it does, is the arrangement of the stones reflect the solstices, so that the rising sun on each of these seasons, on the summer solstice, on the winter solstice, on the equinoxes, rises through specific stone arches in Stonehenge. One of the things that Stonehenge does is at least track the equinoxes and solstices. Other parts of the world, everywhere you go, you can find ancient ways that people had of tracking the different seasonal dates because they told you when to do specific things. People have been keeping track of this forever. Today, it kind of just controls what you wear and maybe not much else unless you're a farmer. But they end up having a big influence on a whole bunch of the other geographic processes that we'll cover in this class. Cool. All right. Have fun.